Okay, here we are at page 3 in 4.2. Again, this section is graphing using intercepts, and then it's also going to work us into this next topic, which is, we just did one where there was only one intercept. It was still a slanted line, but now we're going to find one that also only has one intercept, and it becomes we'll see what it becomes. I won't give it away just yet here. Okay, but let's look at number 48, number 54 here. I want you to watch these examples, and I haven't put lately on the notes that whole TQC, that tell somebody what you're seeing, talk it through, note any questions that you have, bring those to class or to your help resource, and then of course make sure you get everything copied down from the notes, especially things that I'm not necessarily saying or writing, but things that you're thinking and kind of aha moments that you have. Really make your notes speak to you so that they're a resource. Don't have you take notes just to keep you busy. Notes should be a chance for you to really gain some understanding and start building your own method and skills so that you're ready for the test. You can really own it. So I haven't done that lately, but that's a good thing to always do. After you see a couple examples, talk it through with somebody, note the questions that you have, bring those to your help resource or to class, and then make sure you get everything copied down that you'll need so that the notes really talk to you. Okay, let's look at these two examples. Number 48, number 54. What's different about these? You have the equation y equals 2, and you also have the equation x plus 5 equals 0. Well, this is another chance to remind ourselves that the reason we've been learning set notation this term, where we take, when we've solved an equation, we've solved something and we get x equal to some number as our answer, and then instead of leaving it like that, we take it and put it in the French, they're not really French braces. Say we get an answer of x equals 7. We take that 7 and put it here, so that we are saying this is our solution set. This is a solution to the equation. This is a number that you plug in and it makes it work. As opposed to just having y equals 2, because this now, in terms of the context of lines and graphing lines, this represents a linear equation, okay? This is an equation, not an answer, okay? Well, what do we mean this is an equation? Well, let's use the method. It says to graph each equation. We're in section 4.2 where we've been practicing using intercepts. So let's do that. Let's do a cute little 2-point table where we plug in 0 for x and then turn around and plug in 0 for y. Which sounds all fine and good, except that when we look at this equation, I don't see an x. So what do? Well, it's like it's y equals 0 times x plus 2. We did this before in one of the other examples, where when you don't see a piece, it's as if it's being multiplied by 0, because that makes it disappear and go away. So you can plug 0 in for x here, but you can either think of it as there's no place to plug it in, so y just becomes what you see here, y equals 2. Or you could think of it as truly plugging in 0 for x, and 0 times 0 is 0, and you just are left with y equals 2. Either way, you get the point 0, 2 as on your line. And I'll go ahead and write the axes here. This is the x-axis. And you take that point 0, 2, and there's the beginning point to your line. We need a second point. But when you reverse that method and you try, which by the way is the y-intercept that we just found, but when you try to find the x-intercept of this line, the method is to put 0 in for y, but you can't put 0 in for y because it makes a false statement, because 0 does not equal 2. This is a false statement here. So you can't put 0 in for y because the equation is telling you, it says y equals 2, meaning y is going to be 2 no matter what you put in for x, okay? So the equation says y is 2 no matter what you put in for x. That's why it's kind of helpful to think of it as y equals 0x plus 2. There is no x in this. It's 0 times x. So whatever you put in for x, 3, -5, 0.2, -7.5, whatever you put in for x, it gets multiplied by 0, it drops out, and you're just left with y equals 2. So no matter what you put in for x, you could put in 3 for x, and you're going to get the point y equals 2. You know, you could put in 3, 2. You could put in, and you'll get 2 out. You could put in negative 5.5, 2, 4, negative 5.5. Put in that point. You'll still get 2. This is negative 5.5 comma 2. Okay? No matter what you put in, I shouldn't have marked that as I was counting over here. No matter what you put in for x, your y value is always going to be 2. That's what this equation says. Which means that when you connect those dots, this is going to be a horizontal line. Okay? And it has a y-intercept of 0, 2. Okay? And there is no x-intercept. Okay? So that's why this method is great, but it doesn't really help us on some of these. However, it gives us a chance to investigate the difference between a horizontal line and vertical lines and any other just plain old slanted line. Okay? So this is a horizontal line. It runs left to right. Its y value is always the number that is stated here, and x, you do not see x in the equation. So those are the pieces of what an equation that will always create a horizontal line looks like. It's y equals some number. Okay, so y equals some number is the equation for a horizontal line. And in this case, our intercept was 0, 2. When it's just any old number, your y-intercept is going to be 0, comma, that number that the y equals. Okay? Let's look at number 54. You've got x plus 5 equals 0. Well, it kind of feels like maybe we have a regular equation here, but when you look at it, there's no y piece. We had no x piece here, and we ended up with a y always being the same number, which created a horizontal line. Over here, there's no y piece. And in fact, if you were to solve for x, you would subtract 5 here, and you'd get x equals negative 5. Again, we're talking about the equation of a line here. We're not talking about a solution. We're not putting this in a solution set. We're just rearranging this equation. And if you were to then try to use our intercept method of put in 0 for x, put in 0 for y, you can put in 0 for y. There's no y there, so you're just left with x is equal to negative 5. Or you could think of this as x is equal to 0 times y minus 5, or x plus 5 is equal to 0 times y. And when you try to put something in for y, it just falls out because it's getting multiplied by 0. You're left with x plus 5 equals 0, or x equals negative 5. So x will always be negative 5, which means that in that case, we can't put in 0 for x. There is no y-intercept. This does not cross the y-axis. It has a x-intercept of negative 5, 0. And again, I'll extend the axes here so you can see them really clearly. X-axis runs left to right, positive, negative. Y-axis runs up and down, positive is up, negative is down. So there is no y-intercept, it's just the x-intercept here at negative 5, 0. And everything you put in for y, it doesn't matter. You're always going to get x is equal to negative 5, no matter what you put in for y. So this equation, x plus 5 equals 0, or you could rewrite it as x equals negative 5. This equation is saying y is negative 5 no matter what you put in for x. I'm sorry, no matter what you put in for y. So you could put in 5 for y, and you'll still get negative 5 as your x value. You could put in negative 2 for y, and you would still get negative 5 as your x value. Oops, I marked negative 5, negative 3. There's negative 5, negative 2. You could put in 1/2 for y, and you'd still get negative 5 as your x value, okay? Because there's no y to place it in there. X is just set to be a certain number here. Or you could think of it as y is there, it's just being multiplied by 0, and that's what causes it to disappear. So anything you put in for y gets multiplied by 0, it becomes 0. You're left with just that x value, in this case of negative 5. So when you connect the dots on this, you get a vertical line. And this one has an x-intercept. A vertical line has an x-intercept, no y-intercept. And in this case, it's an x-intercept of -5, 0. So in general, if you have an equation of x equal to some number, it's going to create a vertical line on the graph, and the x-intercept is going to be whatever that number is, comma, 0. Okay? So take a moment to talk that through with somebody. How do you recognize the equation of a horizontal line, and how do you graph that? How do you recognize the equation of a vertical line, and how do you graph that? Talk it through in words that make sense to you, and then note any questions you have, and then copy down what you see here. Get those notes complete for yourself. Two of them that you can try here. Y is equal to -3 or 5y equals 20. And we'll try those and hit the pause button. While you do that, come back to see the resulting graphs. Okay, so here's what you should get. You extend those little axes so it's real easy to see them here. And you get x plus or minus, y plus or minus. We'll do the same thing on this one while I have my black pen handy. So here's your x plus or minus, here's your y-axis plus or minus. So for y equals -3, this becomes a horizontal line at -3. No matter what you put in for x, you get a y value of -3. And then horizontal lines, this is a little tip that I'll give you for, well, actually we'll do it in the next video. Sorry, I got ahead of myself a little bit. Okay, for this next one, 5y is equal to 20. What's different? Well, it's being multiplied by 5. If you were to solve this for y, though, to get the y by itself to really see what this equation looks like, it would be y is equal to 4, meaning that no matter what you put in for x, there is no x, your y value is always going to be 4, so this is going to be a horizontal line crossing at 0, 4. And this one is a horizontal line crossing at 0, -3. So hopefully you were able to manage that. Both of them were horizontal. No coincidence that both of them just had a y value. We'll talk about that in our next set of watch problems. Okay, we'll see you at the bottom of the page.